Okay, so in this unit, we're going to look at the concepts of work, energy, and power. And basically, these three are all connected in a way. And there will be a fair amount of calculus in this chapter. We'll do some integrals, we'll do some dot products. We'll look at potential energy graphs and how do we analyze those. And then, so for the most part, some of this stuff is actually just review, especially when we do the basic concepts. But just like I've been telling you guys, how what we're doing now is we're doing basic review plus adding calculus to it. Okay, so let's get started. So here in the first section, we're going to talk about this idea of work, right? So if we talk about work, a lot of times people just think about like physical exertion, right? So this weekend I did work in the yard, right? I went and I raked leaves, which means I physically exerted myself to get stuff done. Okay. Now, one thing you have to note is that in physics, this idea and concept of work, some of that happens when you do what we consider to be real world work, but a lot of times it's actually not real world work. Okay, so let's talk about what is meant by work in physics. All right. So work is just simply, at this point in time, is going to be defined as a product of force and displacement. So in this section, we're going to make these assumptions that the forces are going to all be constant, right? So they're not going to be changing with respect to time, or with actually not with respect to time, but with respect to displacement. And we'll do that. We'll take care of that here in a little bit when we'll talk about variable forces. The symbol for work is W. The unit is joules. Okay, and it is going to be joules because you can see here, it's the unit for all energies and works. Okay, it's named after James Prescott Joule. And right now, the most basic formula for work is there's going to be force times displacement cosine of an angle. Okay, and then one way, and what they'll do on multiple choice questions is they'll have you identify, is work being done, or identify a situation work is being done. And so the way you have to think about it, there's got to be three things happening for work. Okay. First, you can see there has to be a force, right? You have to have a force exerted, right? It's right there in the definition. The second thing is you have to have a change in motion, okay? Again, right, here it is right here, displacement. You have to move. And then the third thing is there has to be a cause. Now, this cause thing is basically as such. This force exerted has to cause the change in motion. Okay. Again, they'll do this on multiple choice questions and say, okay, identify situation work is being done. It may be one of those case 1, case 2, case 3 type problems. All right. Now, any force that acts on the object that is trying to do something to the object will perform work on the object. Now, what that means is that work can be one of three things. It can be positive, it can be negative, or it can be zero. The positive and negative cases, again, this will play into that cosine theta portion. In fact, for AP Physics C, work is what do we call it? Dot product, and we'll talk about that here in a second. So if your angle is between 0 and 90, so 0 degrees is less than or equal to theta, which is less than or equal to 90, not including 90, right? These are the acute angles. Right, and so our work is going to be positive. So that would be something along the lines of my motion is to the right, right, and my force is acting kind of at this angle, because essentially the horizontal components the horizontal component of force goes in the same direction as the displacement. Then we'll have positive work. Okay, negative work happens once we go above 90. Okay, so from 90 degrees to 180, again, not including 90 degrees. Remember, these are going to be obtuse angles, right? And so if my motion is this way, and my force is this way, okay, what happens is it's the X component that's doing the work, and you can see that that would be an angle of 180 degrees, all right? And the last one is zero work. Well, very simply, right, we haven't included 90 degrees in any of our inequalities here. That's because 90 degrees would do zero work, okay? Again, that's going to be a perpendicular. So my force is, or if my direction is to the right here, and let's say my force is pushing on it down, okay? Another way to think about it is you do the cosine of 90, that is going to be zero, okay? Now, because we're talking about all the forces acting on an object, right? That means that you can have net work done on the object, okay? And the way to think about it, oh, sorry, I looked at the wrong spot. So any force, if you have n forces acting on an object, and the object is going to displace, or as it displaces, then there are n amounts of work done on the object. The sum of all these, okay, is the net work done on it, okay? All right, and so if you want to kind of want a mathematical formula, W net, just like when we found force, net force is just going to be the sum of all the works, okay? And any force does ultimately do work, okay, aside from perpendicular forces. And so if you were to kind of break this formula down further, really what it works out to be is simply the net force times the displacement, cosine of the angle, if you have multiple forces acting on the object. If you only have one force acting on the object, it's just F delta X cosine theta. Okay, so here's an example. This talks about a strap pulls a suitcase 100 meters through the airport. The tension on the strap is 20 newtons. How much work does the tension force do on the suitcase? Well, simple enough. We're just going to multiply the two, right? Because it doesn't give us an angle and we're not like looking for friction, we're going to say that the cosine of the angle, or the angle, is just going to be 0 degrees, which makes this equal to 1, which just makes the formula F delta X. Right, and so we're going to do a force of 20 newtons. It's traveling 100 meters, okay, and it's 2,000 joules. And we made the assumption that we were pulling this strap horizontal, okay. If it was at an angle, we would keep this cosine theta in there, and then we would have to multiply it out on off here just to the right of our 20 times 100. Okay, in the next section, we're going to look at kinetic energy, and then we'll look at a relationship between those two.